So let's start with the most important question. What exactly are pointers? Well, pointers are in the end variables that store value addresses instead of values. And that might sound confusing, so let's take a look at how your code affects your computer's memory. And let's say you have some code where you create and initialize a variable called age, which you set to a value of 32. In that case, that value, 32, is stored in the computer's memory. And that value in memory automatically gets an address. Every space in your computer's memory has an address, and that address is required by the computer to be able to retrieve that value and work with it. But in this case here, this value 32, which in our code is stored in the variable age, is actually also stored in the computer's memory. And every value you use in Go is, at least for a short period of time, stored somewhere in your computer's memory. Now, a pointer then is a variable where you don't store a value, but where you instead use this special ampersand operator, a single ampersand symbol, to get and store the address of a value instead of the value itself. So now age pointer would contain the address as a value. And you might, of course, now wonder why you would use this feature, what the advantage of pointers is. And there are probably two main advantages of using pointers in Go, at least in certain situations. And the first potential advantage is that when working with pointers, you can avoid unnecessary value copies. And the second advantage I want to emphasize here is that you can use pointers to directly mutate values. But what exactly do I mean with these advantages here? Well, let's start with the first one, the left one, avoiding unnecessary value copies. By default, in Go programs, when you pass a variable to a function so that that function can work with that value, Go creates a copy of the value of that variable in memory and passes that copy to that function. So at least for a certain period of time, until the function execution is done and the copied value will eventually be cleaned up by Go's garbage collector, a process that runs in the background automatically and gets rid of unused values. Until that happens, you have the same value twice in memory. And for very large and complex values, that could be a problem in certain applications because since you have the same value twice, you're of course taking up twice as much space. Now, I'll be totally honest. For numbers and most strings and also most more complex values, about which you'll learn later in the course, that won't really matter too much in most applications. You'll need a very specific application or a use case where this optimization of using a pointer to avoid this copy might actually make a difference. But still, it is an advantage to be aware of, because that can be one reason for using pointers. Because when passing a pointer as an argument to a function, there's no copy being created. Instead, that function receives the address and can use that address to look up the value that's stored under the address, again by using a special syntax, which I'll also show you later, to then work with that value that is stored there. So that's one reason for using pointers. Another advantage of using pointers can be that you can write functions to which you pass a pointer, so an address instead of a value to that function. And that function can then, since it has the address to the original value, directly edit that value. So it doesn't have to calculate a new value based on the input value and then return that value so that that returned value can be used in the place where the function was called. Instead, it can directly manipulate the value if it received such a pointer. And that can of course lead to less code, since it allows you to avoid the return statement and so on. But to be clear, it can also lead to less understandable code and unexpected behaviors, because it might come as a surprise that a function called add, for example, does not give you the sum of two numbers, but instead edits the first number by adding the second to it. That can be unexpected. You might instead expect a function that returns a result and leaves the original numbers unchanged. So it comes down to your specific use case, your personal preferences, and of course also the naming of your function, so that you don't surprise yourself or other developers with unexpected behaviors. But that's what pointers are and why you might want to use them. Now let's take a closer look at them in code.